Hello guys, welcome to Math City with Miss G. In this video, we are going to talk about transversal and parallel lines proof. Let's begin with number one problem. We are given that two lines are parallel, that is L and M. So I'm going to emphasize this with an arrow to emphasize that these two lines are parallel and it is in the given. We are also given that angle 1 is congruent to angle 7. Yes, they look like the same, and congruent, remember, means equal in measure. So we can make some connections in between, and the only way to do this is to use two-column proof. So let's begin with writing the given as our number one statement. So first, we have number one, which is L is parallel to M, and the reason is given. We have another given, which is angle 1 is congruent to angle 7, and that is also given. Now, because we would like to prove that A and B, line A and B are parallel, so we have to have two angles that are connected to each other, that has relationship. And what relationship am I talking about? It's the angle pairs in the parallel lines cut by a transversal. So each of these angles needs to be attached to line A and B. So one possible answer could be introducing angle 4, because 1 and 4 has a relationship, and then 4 and 7 has a relationship. Let's talk about the relationships. So angle 1 is congruent to angle 4. Why are they congruent? Why do they have the same measure? Because they are considered alternate, they're opposite sides of the line A, alternate interior because they're inside lines L and M. So interior, alternate interior angles. Now, if we are going to go back to statements 2 and 3, there is an angle that's common, and that is angle 1. So since angle 1 is common, therefore in number 4, we can say angle 4 is congruent to angle 7. And this is using the concept of transitive property. Now, going back to what we are supposed to prove, we were to prove that two lines are parallel. Okay, well now we can prove that these two lines are parallel. Why? Because angle 4 is attached to line A, and angle 7 is attached to line B. So then therefore, in number 5 statement, we can say A is parallel to B. And the reason for that is because angle 4 and 7 are alternate interior angles. Alternate interior angles. So we're going to attach the word converse because our last statement, it ended up with parallel lines. So that means in the standard way, we are to introduce, like, here are parallel lines, let's name congruent angles. So that's how it's done in the beginning. Now, since we're doing the opposite of that, we started with, we know there are parallel lines that are introduced, but we also started with angles. And then from angles, we are to prove that the two lines are parallel. So if we end up with lines that are parallel, we are going to attach the word converse to our reason. Let's try another problem. Number 2. So we have 2 given, and we have G and H, which are parallel to each other. And then we are also given that angle 1 is congruent to angle 2. Now, going back to the list of angle pairs in parallel lines cut by a transversal, none of the examples are illustrates the angle 1 and 2. Yes, they look like vertical, but they're not. Yes, they look like alternate exterior angles, but they're not. So we need to use two-column proof in order to show how these two angles have connections, and then prove that these two sets of lines are parallel. So we're going to begin with the given. We also are given with the second statement right here, which is again given. So we need to introduce another angle that has something to that is attached or has relationship with angle 1. And since there's only one other angle here, that's 3, so we can say angle 1 is congruent to angle 3. And these two angles are considered corresponding angles. And from angle 3, we can then make connections that angle 2 and angle 3 are congruent. So in number 4, we can say angle 2 is congruent to angle 3. Now go back to statements 2 and 3. Notice that there's this. And because angle 1 is common, we can then say that this is using the concept of transitive property. And let's go ahead and go over the illustration. So we have angle 2, which is attached to line R. We also have angle 3, which is attached to line P. And because each of these angles are attached to the lines that we were to prove that they're parallel and they have a relationship, which is alternate interior angles, so that is going to be our last statement. P is parallel to R. Why are they parallel? Because there are two angles that are attached to each of these lines, and that is angle 2 and angle 3. These two angles are considered alternate. They're opposite sides of line H. So alternate in exterior because they're outside of lines P and R. So exterior angles converse. Again, we are attaching the word converse with it because we are to prove that two lines are parallel from the given congruent angles, or we have shown that there are two congruent angles that are attached to each of these lines. Let's try one last problem. Number 3. So we have line G and H are parallel lines. So we are to show that angle 6 and 2 are congruent. So let's begin with the given. So number 1, G is parallel to H, and again that is given. We have another given, which is angle 6 and angle 3 are supplementary. And the reason is also given. Now because angle 6 and angle 3, as you have noticed, none of the angle pairs in the parallel lines cut by a transversal illustrates these two angles. So, however, it's in the given and there are supplementary. So we're going to use this given to create the next statement. And we can say that measure of angle 6 plus measure of angle 3 is equal to 180 using statement number 2. And the reason for this is because the word supplementary is introduced. Therefore, we are going to write definition of supplementary. Now, the next statement we are going to use is something that uses either 3 or 6, and these two angles when added together is equal to 180. Now, looking at the illustration closely, it would be angle 2 and 3. Why 2 and 3? Because 2 and 3 are on the same side, interior angles, and they are considered supplementary. They can also be called consecutive interior angles. So the 3 is mentioned, and so we need one of these angles be mentioned. So we can say number 4, measure of angle 2 plus measure of angle 3 is equal to 180 degrees. And again, we did mention that these two sets of angle are on the same side, interior angles. Now, if you look at what we have in statements number 3 and 4, there is something that is common, measure of angle 3. So since measure of angle 3 is common, so number 5 statement, we can say that measure of angle 6 is equal to measure of angle 2. And the reason for that is congruent supplement. So congruent supplements. So that would mean that we are able to find two common angles, and that is measure of angle 3 for each of the statements. And so therefore, we can then say that measure of angle 6 is equal to angle 2. That is congruent supplements. Now, from number 6, we can then say that angle 6 is congruent to angle 2. And our reason for that is definition of congruence. Because if we look at or recall the definition of congruent, okay, it simply means something is equal. So if we're talking about angles, in this case, angles, the measure of the angles are equal, we can also say that they are congruent to each other. So that's definition of congruence. Thank you for watching this video. I hope you have found value. Thank you so much, and you have a great day. Bye.